Let's see, everyone can share my screen. I can see my screen, I hope. Admit these people, all right. Yeah, welcome to STAT 115. This course goes by many different names. I know a lot of you might come to this course with varying levels of experience. Some of you might have never even coded before, and that's okay. Well, it's not technically encouraged. So people have certainly done it in the past, and I certainly didn't have that much experience when I took this course. You just have to work a bit harder than others, and that's okay if you're up for the challenge. This first lab just serves a couple of purposes to go over some logistics. There are some things, some forms that need to be filled out to get access to the computing cluster, for instance. That's decently urgent, so I'll remind you a couple of times. Make sure to do that early on. And then, yeah, so as I said, some people may be very familiar with R and with the command line. And if that's the case, feel free to leave and watch it later if you feel that it's useful. If not, then feel free to skip this one totally. But I'm assuming no prior experience for this lab, so I'll take it slow and we'll go step by step. So I'll keep admitting people to the waiting room as we go. It's my first time TFing a course, so bear with me. And it's also like midnight my time in my time zone, so we'll stick with it. Let's go. So yeah, as I said, this week, a couple purposes. Cannon is the computing cluster that we'll be using for the homework. Sometimes we'll have to deal with large data files, and it's not really fast to do it on your own little CPU on your laptop. So that's why we get experience using the computing cluster. You might see this referred to as Odyssey, because that was the name until very recently, and they just upgraded it and changed it to Cannon. So they mean the same thing. Don't worry if you see them used interchangeably. We'll go over RStudio today. Hopefully you've downloaded it and installed it already. That would be quite useful. If not, I'll leave a little bit of time for you to do that. Go over basic commands, how to get help. We'll spend some time and do an exercise on how to manipulate data. This is actually very useful, and you'll need to do this very, very soon in the course already for homework 1. So it's quite useful to wrap your head around how to filter, summarize, group by, take the mean, and especially use the pipe operator. And then we'll go over the very basics of bash scripting. This is also something that takes quite some practice, but at least I'll show you what the basic commands are and how to navigate the command line. And we'll also point to several other resources that will be very useful as you take this course. So let's get started with some announcements first. Oh yeah, so next week, my friend Philip will do lab number 2. That will be much more focused on Python, a little bit more about the computing cluster, and then homework 1 questions. So some of you might want to start homework 1 very early on. That I wouldn't recommend that necessarily unless you really know what you're doing. Usually the setting up of the computing cluster takes 1 or 2 days. So that leaves us a little later in the week. And then Philip will go over some very specific commands for homework 1. So stay tuned for that. More people in the waiting room. Okay, let's keep going. So this is really important. I know you can't click this link right now because I'm sharing my screen, but please fill in this form, ideally today, right after the lab, if you haven't already. Yeah, as I said, Cannon is the new name for Odyssey. And you really need this to complete the first homework. And if you don't fill it out now, that's a bit annoying. We like to batch all the people who get access right at once. That makes it a lot easier and faster. So Nabib, are you raising your hand?
Have people already gotten access? I filled out the form like on Monday.
Yeah, no, not yet. So
okay,
we set the deadline for, I think tonight, I think we did, and then we'll submit the results to the moderator tomorrow, and then he'll give everyone access. And I'm expecting some people might be a bit late, and we'll have to get them access later, but that will delay you a little bit. So please fill it out. Edward?
Yeah, sorry, just a quick question. Is there an R markdown that we can follow along with, or is it just
yes,
giving the presentation?
Yes, we're going to get there.
Oh, okay, great.
Yeah, totally. Yeah, and everyone feel free to just interrupt me, please. The raising the hand thing works pretty well, but you can also just shout it out. Okay, let's keep going. Yeah, another announcement. we'll use Slack for a lot of questions about the homework. And then we hope that you and your peers can interact. The TFs can answer your questions. For better or for worse, we chose Slack. Other courses might choose Piazza or Ed, but we stuck with Slack. So yeah, please join it afterward.
Could you send the link to the chat?
Say that again, sorry.
Could you send the link of Slack to the chat?
Yeah, we'll download the R Markdown file later that has all these links. I think that might be a bit more useful. So why don't we get to that? I hope everyone has RStudio installed. If not, please do so. It should be quite straightforward to find. And let me go to the GitHub detour. All right, so why doesn't everyone go ahead and navigate to github.com/style115, and you should be able to see lab 1_2021, and then yeah, go ahead.
So is Canon, like, can we do RStudio on Canon, or is Canon just like a place where we can just like what is Canon, if you can explain that?
Canon is the place where a lot of the files are stored that we'll need. So if we have a reference genome, for instance, that we'll need to map our reads to, that will be stored on Canon. And in terms of homework 1, we'll go into a little bit more of the details next week, but you certainly won't need to run RStudio on Canon. So usually what you will do is you submit a bash script to the Canon server, and that will then do the heavy computations for you. But yeah, we'll get to it in a bit more detail. So hopefully everyone can navigate to GitHub. There are several ways you can get access to the RMD, the R Markdown file for this lab. The most useful way that is most commonly done is to go to your terminal and then type git clone and then the link. You should also be able to see it on the big green button on GitHub. The other way is to do download zip, or you can create your RStudio project. I wouldn't do that for now, that third option. So maybe I'll give you 1 minute to figure this out. If you're really new to this and you can't figure it out right now, you can also, go ahead. I thought somebody was interrupting me, that's all right. If you're really new to this and you can't seem to figure it out yet, you can also just copy paste the entire RMD and paste it into RStudio, but this is not recommended. Okay, I'm gonna wait just.
Where are these slides?
Yeah, so these slides were created from the R Markdown file. So it would be nice to download the R Markdown, and then you can what's called knit it. And then I've installed a package that will knit it into a HTML, which then nicely formats into slides. So
is it in files on the website, or?
Let me head over to the GitHub. So lab 2021. Should be able to find it here. And then lab 01. Are you all able to see this? It should be public. And then it's this one, lab1.rmd. But ideally, you would want to go back here and then download everything. So click here, copy this link, or download zip. So if you copy this link, you would have to go to your terminal and type git clone this if you have git installed. Otherwise, you can download the zip file. That's another way to do it. So
okay. Can you go back to the installing GitHub?
I'm sorry?
Can you go back to the previous slide on like installing GitHub or register? Yeah, that one.
Yeah, sure.
Thanks.
Sorry, may I ask a random question about homework 1? So will the lecture cover anything useful for the homework?
Yeah, so in general, yes. The answer is yes, because while you may be able to figure out how to use the read mapping software like STAR, for instance, on your own, the lecture will cover what is actually going on. So in that sense, it's really useful. So yeah, I would really attend the lectures. I found them, even rewatching them, I found them really, really useful.
Our lecture's
Sorry,
gonna be. Oh, I'll let Mark go.
how do you how do we clone it exactly? Because I don't have the clone button.
Yeah, so if you haven't cloned before, I would recommend just downloading the zip file and then you can open it. But if you let me, I can try and open up my terminal as well. Here, let's see. Oh, you might not be able to see this, right? No.
No, we don't see it.
Yeah.
But our lecture's gonna be live. Cause like Professor Lou said that like sometimes lectures will just be recorded and then posted from last year.
Oh, okay. I think in general they should be live, but if you mentioned I couldn't attend today in class, but yeah, last year's lectures are all recorded and on YouTube, and some of them might not have changed, so she might choose to just post them then. Okay, I will.
Are they available for us?
Yes, they are. I can send everyone the link later in an announcement as well.
Thank you.
Yeah. If anyone still has questions about this, please let me know. The easiest way is just to go here and download the zip file with all the code, and then you should be able to open the lab1.rmd in RStudio, and you should be able to follow along especially if you scroll down to approximately line 120 or so, a little later, you should be exactly where I am. Yeah.
Sorry, Martin.
Yeah.
I did the git clone and then the URL in terminal, and I think it worked because it unpackaged all the objects or whatever. But where does that go? Like, how do I access that?
Yeah, so this should be in your current folder. Then you can type ls in your terminal. Then it should show you all the files in that current folder. You can also just go into Finder on your, that's what it's called on Mac, and just browse all your directories. And then, so if you're in the terminal, it's always operating in a current directory, which you can see the contents of by using ls. We'll also get into this a little bit later, but yeah, let me know if you're not able to find it.
I don't see the clone or download button.
So
after clicking lab 2021 and then lab 1.
yeah, just the clone or download button is for lab 2021 folder only, because that's a repository. So just go back one step.
Oh,
yeah,
I see it.
Yeah, just let me know any questions. I think for now I will try to move on. It's not, if you haven't figured it out yet, it's not super crucial that you follow along in the R Markdown, but it would be a little nice. But I'll just move on in the interest of time. But let me know if there are any more questions. So why we're using R Markdown in the first place is because it's reproducible. That means you can do write code in R Markdown, then knit the entire file, and you're able to share it with others, and everybody should get the same document. Especially if you're doing statistical tests, for instance, statistical simulations, this is very useful. You can set a seed, is what it's called, and you will get the same numerical outcomes in R Markdown. And yeah, this has made it highly used by a lot of statisticians. You will see some similarities with other programming languages like Python, but also keep in mind it was developed for data science tasks, statistical tests, all those types of analyses. And it's also widely used in bioinformatics, which is why we teach it here. So if you're able to follow along in the R Markdown, you can see that there are different ways to write text and embed code chunks. You can write big, kind of big, and still biggish letters. Yeah, you can write stuff in bold by using the asterisk, or you can italicize text, and you can even add LaTeX. You won't have to do that for this class probably. And you can also add inline code. You can add images if you use an exclamation mark and I think square brackets. And you will see in R Markdown, you will see different chunks. These all can run code. And note that you can add certain parameters in the header of these chunks. So for instance, you can say echo is equal to false. And in that sense, it won't show the code chunk when you knit the report finally. There are several ways, several different parameters you could add here. One is echo, one is include. There's several others as well. Let me move on. This is neat. You can embed plots. So actually, let me back up just a little bit, because I skimmed over this before. But if you're, this is really useful to know. R is very useful, especially in bioinformatics, because there are many different packages written that can help do very useful tasks. A lot of these packages are in CRAN. That's a project. I think it's just an aggregator of many different packages. At least it has a neat functionality that you can do install.packages and then the name of the package, and it will pull the package from CRAN. You'll be able to use all of its functions. You'll only be able to use all of its functions once you load the packages into your file using library. So there's a package called New York City Flights 13 that you first can install. If you then put it in your library, you'll have access to all of its data. And if there's any functions written in it, you also have access to the functions. So this is, yeah, go ahead.
Where do you do the install.packages? Do you do that within the R Markdown file?
Yeah.
Or do you do that somewhere separately, like globally?
Yeah, so yeah, in the R Markdown file, you have, okay, I just saw a chat message. You have different chunks that you can run. Usually you might put install.packages into one of these chunks. It's hard for me to navigate to R Markdown right now, but while I'm sharing my screen, but
I guess, do you do it like for every time you make a new file? So like if I made a new R project, how do you do the install packages again?
Well, let me remember how this works. I think once you are in R Studio and you have an active session and you type install.packages New York City Flights 13, it should keep it installed. Perhaps until you terminate the R session, or maybe even after that. I don't quite recall that, but I can get back to that. But you don't have to, you usually don't have to re-put it every single time. But know that if it gives you an error like package not found or something on that order, then it's usually this is the case, that you have to do install all packages. Yeah.
Yeah, the installation is done only once, and then you can just use library to load it.
Yeah, thanks, Jack. So that's really, so only when you're just getting started, you have to install packages. Okay, let's keep going. Yeah, so you can embed plots. We'll get into what's called ggplot a little later as well. This is a neat package to create beautiful plots. But note that this is very attractive in R Studio and R Markdown, that you can just embed these plots neatly. So here, for instance, you will put ggplot in your library. We'll put dplyr, we'll get into that later as well, in your library. You take what we have here is a flights data set, and we'll get into all of this later, but I'm just showing what's going on here. A pipe operator, this will say, take in the flights data set that we have here, take that output as as input for the next operation, and you'll get to play around with all of this a little bit later. Don't worry if you don't understand it now. I'm just trying to go through this. And then it will say plot. Put the origin on the x-axis. So here we see different airport codes. And then on the y-axis, we put the arrival delay. I'm assuming this is in minutes. And it will show a box plot. And then you can add the title, and you can add all sorts of legends, titles, different axes and labels, which is very useful in ggplot. But we'll take this more step by step. Just know that using plots in R Markdown is very convenient. This is also, when you're starting out with R, this is often a source of errors and confusion. Note that if you try to load in a CSV file or a data set, for instance, this file will, you will have to specify its location with regards to where you are in your working directory. Your working directory, usually when you haven't done anything, you just open R, it will be wherever this R file is saved. But you are able to change the working directory. So if you type in getwd with the parentheses, you will see your working directory right now. And you can also change it. You have to put in a valid path here. So for me, that would be something like /user/Martin/documents. But you can set it to wherever you want. But note that if you get an error, if you are sure that, say, a CSV file like New York City flights, oh, sorry, that's not a good example. New York City flights is in a package preloaded. But say you are using a CSV file, you're sure that it's in your current directory, but your R Markdown is not able to find it. Then it's usually that this is the issue. You have to set the current working directory to be in line with where the CSV file is located. Just very basics of R. R has basic commands and data structures, 6 basic data types, out of which a couple are more important than others, but it has a character, a numeric, an integer, a logical, and a complex. I've never used a complex before in my entire working life with R, but characters are very useful. These are essentially the equivalent of Python strings, or yeah, numerics. Integers speak for themselves. I've actually never used integers either myself, I think. So numerics are certainly very widely used, and logicals are true or false. Then there are many data structures in which you can store these data types. So there are atomic vectors. Atomic just means that every element in a vector is of the same type. So you can have a vector that says A, B, C, D, having 4 different elements, and they're all characters. You cannot have a vector that is A, B, 1, 2, because there you would have 2 characters and 2 numerics. A list is more flexible than that. A list is able to contain many different data types. It's not very widely used in R like it is in Python, because R is very feature. What is nice about it is that it's vectorized. That's why you won't often see lists, but they do exist. Then there's a matrix. A matrix is an atomic vector with a dimensionality component. So you can have a 2 by 3 vector essentially. So a matrix is also atomic. All the elements will have to be the same data type. Actually, the slides after this show this in a little more detail, but this is just a brief overview. A data frame is what I would use most and what most people would use. This is not so different from a matrix, except that I think it can contain different data types. And then a factor is also, how do I explain? It's also a vector, but it will be, maybe I'll save this for later, but I'll try to explain. If it's confusing, that's okay. I think a factor is a vector where each element can only take on a certain number of states. So you might have a good example is a factor vector could be colleges in Boston, and you might have only 20 or so of them, Harvard, MIT, Northeastern, whatever other colleges there are. The vector cannot contain any, cannot contain Stanford, for instance. I hope that explains it. I hope that explains it a little bit. So let's go over these vectors in a little more detail. You create a vector by assigning C with, in parentheses, the elements of the vector. So this is a numeric vector. You can have 1, 2, 3, 4, 5, and assign it to the variable x. Then you can index this vector with square brackets. So you can print the first element of x, and that will be 1. Then you can perform operations on the entire vector at once, on each element. So if you square this entire vector x, you will get the squares of each of the components. So 1, 4, 9, 16, and 25. The same if you take the square root. It will apply to all the elements of the vector. And this is quite neat. You won't even have to do a for loop or anything. It just does it. A vector can be logical as well. So logical, remember, is just a Boolean, a true or false. So if we think about what's going on here, it's taking x. X is our vector defined up here. And then it's subsetting it. It's indexing it by a logical vector. This logical vector, x is smaller than 3, will be a vector showing the places where x is smaller than 3. So this vector will just be true, true, false, false, false. Smaller than 3, smaller than 3, not smaller than 3, not smaller than 3, not smaller than 3. So if you index by a vector that's true, true, false, 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 it's just going to show the first two elements that are true. So in this case, the first two elements of x, 1 and 2. Feel free to re-listen to this later as well. So then, as I alluded to, a matrix is an R vector with the dimension attribute, also atomic, meaning it can only contain one type of data, one data type. So if you want to create a matrix Y, this just means you fill it up with values 1 through 8, with 2 rows and 2 columns, and this means you fill it up by column. So you can imagine you could fill up a 2x4 matrix with the numbers 1 through 8 in 2 different ways. You could have the first row 1, 2, 3, 4, second row 5, 6, 7, 8, or you could have first column 1, 2, second column 3, 4, third column 4, 5, 6, last column 7, 8. So this just specifies how you want to fill it. This function can show you.
就是它，不是它有什么，就是相当于这那个叫什么快捷键，就看他平常一般看什么。
哦，看你大屏。Fuck.
Okay, I'm not really hearing that so well, so I'm just gonna keep going. So you can index this matrix in several different ways. You can take the element in the first row and the second column. In this case, that will be 3, because remember, we index it by column or not by row. You can access the entire second column. Then you will leave this first place blank. You use a comma and then 2. Oh, damn, I keep moving it around. Let's go back. And then the command dim will give you the size of Y. So note, here are 2 rows and 4 columns, just like we specified up here. And this operator at the bottom, the %*%, this is for matrix multiplication. So this is often an issue. You can't just use a star as you would intuitively think for 2 matrices. You actually have to use this operator. So as we alluded to, a list in R is not super widely used, but it does exist. It's a generic vector containing other objects. So this is just a contrived example showing how a list can contain first a character vector, a vector with 3 elements, namely January, February, March. The second element of the list is a matrix with 2 rows. And then the third element of the list is another list with first a character and then a numeric. So as I said, you might not use this very often, but then there are several functions. You can call the function names, which you can then assign the different names of the elements. And then you can again show the entire list as follows, and then it will show you all the elements. This is much more widely used. A data frame. This is just a list of R vectors of the same length. And note again, these don't have to be. This entire data frame is not atomic. It can contain many different elements. So this is very useful for most data sets you might have, whether it be the weather, whether it be the stock market. You might imagine many different vectors, not with all the same data types. They're probably not all just numbers. They might also have a name. So that's why a data frame is very useful. If you're following along, I encourage you to play around with this, to type data empty cars and then run it. Because it's a very famous data set, and you can see how a data frame is structured. I already show you here. Str empty cars will give you a list of numerical vectors. So the data frame will have many different columns. I think this is miles per gallon, cylinders, dispersion, displacement, I'm not sure, but lots of different numbers associated with different attributes of the car. Feel free to ask me any questions if you cannot seem to load this data set. But for now, I'll move on. So here, if you do empty cars 1, 1, you'll get the first row and the first column's elements. So you see that it's this one, this 21. The function head is very nice because it can quickly show you the first, I think by default 6, but you can specify with another comma and then the number of rows you want, but by default 6 rows of the data frame you have. And here we're actually not showing the entire data frame, but we're just taking the first column, the miles per gallon column. So that would show you this if you were to run this. This is a little bit different because now we're not just subsetting the first column of the data frame, we're subsetting that again, taking just the values of the first column of the data frame, just taking the atomic vector. You would do that by using double brackets.
Martin?
Yes?
What does this 1 that keeps popping up mean? Just like, is it just the first line? Is that what that means? The one in brackets for when you get the results?
Yeah,
No.
right.
Right next to the output. So if you get an output here, we have an output of the.
Oh, okay. Here, what does this mean? Yeah. Good question. I think. Yeah, I'm not quite sure. Is that meaningful? I'm assuming it's just the first line of the output, but
okay.
Think about that a little. Yeah, I wouldn't.
I think it's for the first element. If we get multiple lines in the return, then there would be the indexing for the start of the next element.
Well,
like,
I don't.
For example, if you show a 10.
Yeah.
So we tried to do the second element of it in the previous slides, and it was still 1.
Go back to
But Mark, I think that's because it's the first element of your answer. So like, for example, on the line that produces the answer, if it goes onto a second line, then there would be another number in a bracket that would be like 9 or 10 or 11 or something. That represents the index of the return.
Okay. Yeah.
Oh, okay.
Thank you. It's always nice when other people can step in for me. I don't know.
Martin,
Yeah.
What does head do? Like, what does it mean specifically? Like the command head.
The command just means print out or show, or the first X, or first you can specify, but by default it will take 6 rows of the data frame. So if you have a very large data frame with, say, 200 lines, it's very inconvenient to print the entire thing. To get a good sense of what it looks like, you might call head, and then it will show you just the first 6 lines. So you'll see all the columns. Yeah. Then there are several apply functions in R. I myself not a big fan of them because I prefer to use all the functions that we'll get to later in dplyr and tidyverse, but this is built in R without requiring any other packages. So this allows you to apply a function across all columns, for instance. So in this case, we would sapply the function sum to all the different columns of empty cars. So in this case, it would add up all the 30 or so rows for MPG, for SIL, for DISP, etc., etc. Yeah.
Wait, Martin. Yeah, that car does have a 6. Is that supposed to be right? It's 642.9 miles per gallon.
No, so that's the sum of all the 30 cars in the data set.
Oh, okay.
Because we just
like, that sounds odd.
Because that's the use of sapply, right? You can take the function sum and apply it to all the columns of the data frame all at once. in many other programming languages, you would have to write some for loop for this. And
right, I see.
Their internal implementation of a for loop, essentially.
Okay. And then we can just change some to some other function.
Yes. Yeah, you can do many things.
Okay, cool.
You can do mean, for instance, or yeah, whatever.
Yeah.
Okay, this is how I prefer to, and basically everyone, I think everyone I know prefers to manipulate data. This is dplyr. Dplyr is also included in what's called the tidyverse or a tidy universe. This is a group of packages with all sorts of useful functions that can make data transformation and just doing different wrangling tasks very, very easy and quick and very readable. So yeah, it's very, very useful to know these. And there's only a couple operations that are really widely used. So I'll go over them right now, and I'll have an exercise for all of you. So we're again looking at the flights data set. We can take the head to see what it looks like. It's too many columns to print on the screen here, but see there's a year, month, day, departure time, etc., etc. One operation you might want to do is filter. So here we're simply selecting specific rows based on conditions that you can specify. So for instance, if we wanted just flights on January 1st, we could do filter from our data set flights. Month is equal to 1. Note the double equals here. This is very important. And day is equal to 1. But you could do this for all sorts of columns and with as many conditions as you would want. So another thing you might want to do is select different columns. Some columns might be superfluous. You might not need them. You might only want to see a couple of them. So you can select from our dataset flights, columns year, month, and day. If you want to deselect or just get rid of one column, you can do select flights and then minus year, for instance. That's much quicker than manually typing out all the other columns that you do want. This is useful. Mutate. If you want to add new columns, especially based on other columns that you already have. So for instance, in our flights data set, we have an arrival delay column and a departure delay column. So think about it, if a flight has less arrival, let me think about that. If a flight has more arrival delay than departure delay, that means there's some gain in delay. That's what I was trying to show here. So if you want to see how much more delay did this flight obtain while flying, you could create a new column called gain, and it will just automatically subtract the departure delay column from the arrival delay column. Same here, you could take the average speed by taking the distance column, dividing it by the airtime column, which is probably in minutes, and then multiply it by 60. So the mutate function is useful for creating new columns based on columns you already have. Then you might want to arrange or sort a data frame by columns. So usually you might want to sort by one column, for instance, the year, but in this case, we want to arrange by an ordering of different columns. So we might want to arrange by year first, then month, then day. So this will arrange ascendingly, I think. So it will go from low to high. You can also arrange descendingly from high to low. I think then you will have to supply an argument called desc, DESC, but I have to double check on that, I think. But yeah, so this is useful for arranging a data frame. It will sort it nicely by the values of a certain column. Oh,
and Martin, all of these functions you're showing us is only for this data frames, applicable to data frames.
Yeah, I think so. I think Tidyverse works with data frames, but or I think more properly called tibbles. Tibbles are just data frames that look nice when you print them. But usually when you have a matrix in R, you might also be able to convert it into a data frame. Yeah, for now, just let's keep working with data frames. So here, yeah, as I alluded to, if you want to sort in descending order, you just the desk in front of the column you want to sort by. And then this is the most powerful one. It's a little bit harder to understand, but you can easily summarize certain columns with the summarize command. Here you can, for instance, easily take the mean of the departure delay and quickly show that in a data frame. So if you summarize from your data frame flights, you will call your new summary essentially delay, and you'll take the mean of the departure delay column. And this just means you get rid of all the missing values, all the NAs in the data frame. Then it will quickly summarize this for you and neatly. So this is quite powerful, especially if you combine it with group by. So let's walk through this slide. The true power of dplyr is its capacity for split apply aggregate workflow. First, you can group by a plane and then summarize the number of flights, average distance, and average delay. So what we're doing here is we're grouping all the flights by tail num. I think it's just the serial number of a plane essentially. Then we are summarizing this grouped by data frame. We're saying count is equal to n. That means the number of rows per tail num. Dist we call the mean distance, and the R delay we call the mean arrival delay. So then here you can see a very first we're doing some other steps, some filtering step, and then you can see a very neat tiny data frame that's grouped by the tail number. So for this particular plane, you have 371 flights with this average distance and this average delay. So this is quite powerful. The pipe operator. This is an example of what you don't want to do, and then we'll show why using the pipe operator is useful. So this comes into play when you are trying to do several consecutive operations. You might want to filter first, then select, then summarize. Naively, you might do this way. You might just take your flights data frame, group it by certain columns, assign this to one new data frame that you call A1, on which you then select. You make a new data frame called A2, on which you then summarize. You make a new data frame called A3, and you have a bunch of these data frames that you're defining that you don't really use anymore later. And this is not really good practice. You're wasting all these variables, taking up storage. It's very unreadable. Fortunately, there's a nice solution for this, and that's called the pipe operator. One other example that's very ugly. You are making this very unreadable by doing all these filter, summarize, select steps all inside each other, and it just doesn't look so readable and beautiful. So this looks a lot better. With the pipe operator, you can turn a function of x and y into, you can just write it as x, pipe operator, function of y. So what that just means is you can start with the flights data set, and then you take that as input to the next operations you're doing. So then you take this flights data set, you can group by year, month, and day, and then whatever that spits out, you can take in as a new input to your new operation. You can select several columns, and then whatever that spits out, you can take as input to your next operation. So this is much more readable because it just shows you start with the flights data set, then you're grouping by certain columns, you're selecting certain columns, you're summarizing, you're filtering. It's much more readable for others and for yourself as well. Then, yeah, you can combine it just with several other functions as well. So if you want to think about this, you feel free to do so. So if you have your flights data set, you can filter by the origin. So I think this is Newark or something. And you can group by destination, summarize n equals n parentheses. This just means take the number of rows and then arrange. So what this ends up doing is it takes all the flights with origin Newark, it groups them by the destination, then it summarizes them by taking the number of rows. So, and then it arranges them in descending order. So what this gives you is the top 10 destinations from Newark in terms of number of flights.
So
yeah.
Just a quick question about the group by. When it group by, like in that first step, right? Does it just like order all of the data? So like now when you look at the whole data frame, you're gonna see everyone. You can see like the first n columns are just like Ord, and then the next n column is gonna be like Boston, so on and so forth.
Yeah, good question. So I'm not sure if it's possible to just do group by. It's almost or always it's used together with summarize, I think. And so it will essentially, so it will group it by destination, and then you will give it some command to summarize on. So it's a good question. Oh, somebody still in the waiting room.
Yeah. And I guess what does it mean when you say group by two variables? It just mean like they're just gonna get every pair combinations of those two variables. So if you did group by destination and like year, it would do like Ord 2019 or 2020, so on and so forth.
Yes, that's exactly right.
Okay.
Okay.
Question on the previous example.
Yeah, go ahead.
With the pipe, one back. So the select gives you a data frame as the output, right?
Yes.
And then in summarize, like, so it automatically populates like the first argument of summarize with the data frame, because usually summarize I think has 3 arguments. So how can we know like when pipe will work, when it will not work?
I'm not sure if I fully understand your question. You're saying it automatically populates the first argument of summarize.
Yeah, because I think summarize has to be so the first argument of summarize has to be a data frame itself, right? And then
no, so that's exactly why we're using the pipe. So usually you would have to summarize, which takes in some data frame. But oh yeah, now I understand your question as well. So yeah, it automatically fills in the first argument of summarize, which would be the data frame you're using, because you're using the pipe, and the pipe tells it use whatever data frame you have obtained here from all your functions and take that in summarize. Yeah.
So now what if hypothetically there was a function where the data frame came as the second argument? Would that be possible to do with the pipe?
Ooh, good question. I don't know the answer to that, frankly. I don't think I've seen that before either. Where?
So maybe okay. So maybe that doesn't happen in practice.
Yeah, it's a good question. Yeah, I'm not sure. I'll have to think about that.
Okay, thank you.
I have a little exercise. If you're very sneaky, you can see the solutions below this in the R Markdown. But I was planning to give you 5 minutes to just go and try this. This might be way too long or way too short, depending on where you're at. That's totally okay. But I think the best way to practice these operations is to apply them. So I've included a data set from an actual clinical trial. This contains several variables, so treatment, sex, age, and several trial-specific indicators. I think this is a breast cancer chemotherapy trial. And then the column E-type indicates the event of a death or a recurrence. So a bit morbid, but bear with me. We've seen these functions for transforming data. And then I'm going to give you the following exercise that I'll give you 5 minutes to do, so I can have a glass of water. And make sure to use the pipe operator on this so that it doesn't look very messy. So let's remove the column called study because it's not useful. Let's filter out all the rows. Sorry, I'm already giving away which operations we're using, but that's okay. Let me not do that. We only want rows with E-type 2. Let's create a new column and round the time to months. For simplicity, just assume a month has 30 days. Then we can sort our data frame by age from low to high. And then we can try and show a simple summary. So we want the average survival time in months grouped by the different treatments that people obtained. Yeah, 5 minutes up. Let's keep moving. Actually, oh yeah, I'll show the solution first. You're already able to see this, but let's walk through it. So doesn't it look neat? We have our colon data set. We deselect the study column with using the minus. We take whatever data frame that puts out using the pipe, and we take that as input for our next operation, where we filter out the E-type. or we filter in the E-type, I should say. We take only those E-types that are 2. We mutate, we create a new column called time, which is our previous column called time divided by 30, and we round it so it's neat. Then we arrange it, so sort it in by age. Then we can, this is the harder one, we can group it by treatment and then summarize. So by treatment, it will show you the average number of months, which is the just mean of time. So then this is what it will output. Good thing is that people in this clinical trial ended up living longer with the new treatment. So I guess that's a good thing. Let's keep going on. And actually, yeah, I'll go. We're almost done with the R part after we quickly show ggplot. Then I plan to cover a little bit of bash, but before we do that, I'll show the steps for getting onto the computing cluster, because I think that's more important. And in the interest of time, I'll cover that first. But let's stick with ggplot for now. This is too much to explain in a slide or two. You really have to practice with it, but it's a really neat way to plot your data frame. They have all types of different plots that you can choose from that are pre-made. They will give it nice coloring, and you can basically specify all the different parameters that you want. So for instance, this is a plot of arrival delay in minutes by month. It shows the box plot, and it colors it by the different airports. Yeah, so this is how you would do it. Note that instead of the pipe in ggplot, you will use a plus. I'm not sure why they chose this. I guess it's not exactly the same as a pipe, but if you want to do different operation in ggplot, you have to do a plus. Yeah, I know that you can. This takes practice. A little hard to wrap your brain around. Here you're saying you're specifying what you want on the x-axis and what you want on the y-axis. On the x-axis, you want month as a factor. So remember, a factor is a vector with only a specific set of possible states, essentially. So this will be a factor with 12 different states. I'm presuming you could also use this as a numeric, but here they chose to do a factor. On the y-axis, you have the arrival delay, and the color is the origin. So you don't have to specify anything. You just say, I want the column origin to specify the colors of this plot. Then it will automatically do that for you. I'm sure you can even assign which airports you want to be which color, but it's not showing that here. And then you're saying you want a box plot, you want this title, and these X and Y labels. This is another example. Yeah, I'm not sure we'll need to run through that now, but so ggplot is super useful for plotting and much more beautiful and versatile than R's inbuilt functions for plotting. So that's why we recommend using it.
Okay.
Yeah. Okay. For now, let's see. We have 25 more minutes technically. I want to leave some time for questions, so let's go through the basics of bash. What is bash? Bash is a command processor that typically runs in a text window where the user types commands that cause actions. Bash can also read and execute commands from a file called a shell script. You might think, why do we use it? Why do I have to learn all this complicated command line stuff? Where usually I would just click, copy, paste, all the things I'm used to. So the first reason is when you just simply don't have a graphical user interface, no mouse, no icons. You would have to run something from the command line. That's how people on Linux typically work. But the second one is more important. If you want to execute a command for 100,000 times, or if you have to open 100,000 files, this is way too much for you and your mouse to click. So it's very useful to learn these commands, and especially when you're using genome data, for instance. So there's a couple commands to be aware of. The cd command is to change directory. So you could do, if you're in a directory which has a subdirectory, say your subdirectory is called homework1. You could just click, you could just type cd homework1 and it will navigate you into that folder. That's just the same thing as clicking a folder in your Finder window on the MacBook otherwise. So that's the equivalent. ls is a way to list the directory's content. And then it's good to know that in general, there are several aspects to a command. So you have a command, its options, and its arguments. And it's crucial that the white spaces are what separates these. So in Bash, white spaces are crucially important. It's very different from R and Python, where they don't matter so much. The only way Bash is able to interpret which is a command, which is an option, which is an argument, is if you use the white spaces correctly. So be aware of that. So here we have a command, ls. We have an option. I'm not actually sure what this option does, but then we have an argument. This one I know what it does. The command is wc. That's I think it stands for word count. Option is L, which means lines. So that means count all the lines. And the argument is the file in which you want to do this, states.txt. I actually think we have all these files also in the GitHub folder. Much like in R, there is a pipe in Bash as well to stream the output from a previous command as the input of a subsequent command. So if you want to count the number of lines in states.txt, and cat, I think it stands for concatenate. It's just a way to print the contents of a text file usually. So if you want to print the contents of a text file and then count the number of lines, this is a way to use the pipe conveniently to do that. What will happen when you use yes pipe head and then option N5? Much like in R, this just lets you show the first 5 lines of the output. And yes is in Bash. If you try it, you might need to do Control-C after, because it will just give you a infinite number of yeses. So the pipe is a little more advanced here. The pipe is actually able to it will give you the essentially just 5 Ys, because the yes command will just give you Y endlessly. The pipe here will know to stop that and take the top 5. Correct me if I'm wrong here, Jack. But you don't need to.
Version of,
yeah.
Sorry.
Go ahead.
Which version of Bash should we download?
Oh, good question.
Because I didn't see any documentation specifying.
Yeah, I mean, I'm assuming you're. I mean, I'm working on a Mac. I'm not sure how it works for Windows and stuff, but I'm assuming it's already downloaded, honestly, on like, because this is the language that you oftentimes use in your terminal.
You can change the default shell to Bash on Mac OS, but I'm not sure what that means.
Yeah, let's let's go back to this after, okay? Because I'm not so sure how to help you with that right now, but I can help you with that after, and maybe we can put out an announcement if more people run into the same issue. Okay. Yeah, sorry. For now, know that if you want somebody to explain better than me, you can use man and then the command you want help for to get some help, and it will show you quite a neat explanation. So Bash itself is a little programming language. To fully extend its power, you'll need to write a program. So a text file with a header specifying which program to execute the file. To write a program, you will need an editor. Vim is one of the options. You'll have to download it. It should be straightforward to find. I'll go over the very basics, and I can maybe do a little demonstration. To get started with Vim, you will need to do vi and then the file name. Why is this important? Well, you might not have another choice on cluster or cloud virtual machines. Let me try if I can do just a very quick demonstration here. First, I'll show you the basic concepts of Vim. You don't need to be an expert in it. I'm certainly not. Most of the time, you'll write a program locally and then use a file transfer tool. For instance, file to Canon. Vim, the way I use it, let me try and stop sharing my screen and then share it again on a different desktop.
File to canon means like FTP or?
I think, yeah, let me get back to you on that. I'm not so sure, but can everyone see this? I just have a little test folder here. Let me see what's in here. I have two little scripts in my folder, hello.sh and math.sh. These are also in the lab folder on GitHub. I can do vi math.sh. This will show you the contents of this file. So I'll get into this a little later in the slide, but we have a first line here. This is this is specifying which program we are using, namely bash. And then this is showing it wants to, we are saying it needs to evaluate certain expressions. 5 plus 2, 5 times 2, 10 divided by 2, 40, what's that called, modulo 21. So now we are in Vim, right? So if I want to insert something into this file, I will need to click I. Now I'm in insert mode. Now I can actually make changes. So how you would usually, if I want to make this 20, that's possible. And then to quit the insert mode, you will just press escape. And then if I'm satisfied with the changes I made, I can do, I think it's colon WQ, and then it will be saved. So now, if we recall what expressions we tried to evaluate, we can see if it turns out right if we do bash math.sh, and it evaluated them. So it ran the program. All right, you can use I to switch to insert mode, escape to go back to command mode, and several tools for navigation. This one is important for saving and exiting, and this is for exiting and not saving. Here I'm linking to a couple of tutorials, even games and cheat sheets that are useful to learn Vim and become an expert at it. So in the interest of time, let's breeze through this a little bit, but we have a couple of scripts already written in the GitHub lab folder. This is how you would write a script in Vim. So say a script called hello.sh. This is what we would write. First, we would start with a shebang, I guess is how you say it. This is used to tell the operating system which interpreter we're using to parse the rest of the file. So here we're saying use bash. That's what you need to take away from this. And then we're saying echo hello world. And then if you then actually run this file, it should just print out hello world. As I just showed in my little tutorial, you can also do math in bash. Really crucial that you actually use the white spaces. As I said, that's the only way bash can interpret the order of things and actually interpret it correctly. So you can't, like in Python or R, you can just type 5 plus 2 with no white spaces. These are very important. And then if you want to run this file, you would just run bash math.sh and it will evaluate it. In bash,
is this on the terminal doing the bash commands?
Yes, this is on the terminal.
And if you're like my terminal is bash, should I turn it like back to shell?
So are you saying maybe bash is not your default shell scripting language? Yeah, well, we need to address that a little later. I apologize if it didn't make that clear, but yeah, I'm not
okay
right now, but okay.
I'll figure it out.
No, we can help you with that. But we'll just do it after the lab. Yeah, for now I'll show you. You can assign data to a variable using the equal sign in bash. You can say variable lab number is equal to 1, and then we can echo $sign lab number, and it should say 1, and it does. We can call variable the Empire State New York, so we can also use a string here, and then we can echo the variable, which we then call with the dollar sign, the Empire State. All right, so you cannot use a white space after the dollar sign here. That's important. And then using the let command, we can actually modify the value of a variable. So if we want to make lab number 1, we want to make it 2. We would say let lab number is equal to dollar sign lab number. That's how you access this variable plus 1. And this should output 2. So occasionally you might want to run a command like you would on the command line and store the result of that in a variable. So then we would do this by wrapping the command in a dollar sign and parentheses around the command. So here, if you want to, again, in our states.txt file, which just has all the 50 states of the US, you want to run this command, essentially counting all the lines, so it should be 50. We can then save that into a variable called state n by using a dollar sign and these parentheses. And then it outputs there are 50 lines in state.txt. Something you might want to use sometime.
What does let do?
Let lets you modify the value of variable. So you can assign a variable just like this using the equal sign. Then if you want to modify it later, you can use let.
So you wouldn't be able to modify without using let?
I think you can. I'm pretty sure you can just read. If you call the lab number is equal to 3, it would just be 3. But if you want to do some arithmetic on it, you might not know the previous value of lab number, and then you would have to use let. Does that make sense? So yeah, you can just rename it, but if you want to do some arithmetic or modify it, you would have to use let.
I see. Thanks.
So note that bash takes in positional input. So if you, let's see, this is the var.sh file that we also have in the folder. It's written like this. So it shows use bash. What this file will do when we run bash on it is it will say script. Yeah, let's just look at it below. This essentially means take all the arguments that we supplied when we ran bash. So when we run bash on this script and we give it these inputs, A, B, 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 and C. These are ways to retrieve the positional inputs that we supplied. So this will give you all of them with the $@ at. $1 will give you the first argument, A. $2 will give you the second argument, B, B, B. And then $# will give you the number of arguments that were supplied. Yeah, you could also ask users to type in a string on the command line by temporarily stopping the execution of your program using the read command. So if we look at let's read.sh, we say type in a string and then press enter, and then you can write down read response. So we store what is entered by the user in a variable called response, which we then echo. So if you run this, it would ask us to type in a string. We would type it in, and then it would just echo it back to us, saying you entered the string we entered. This is a little more advanced. Conditional execution. It's important to know that each command has an exit status. So the exit status informs you if something works as expected. If I enter the name of a command that does not exist into the terminal, then I'll see an error, not 0. So if you just type this into the terminal, this is not something that exists. And then you echo, this is what's called the exit status, the $sign. Here it will give you 127. 127 is command not found, essentially. If it runs successfully, it just gives you exit status 0. Because here you are saying echo, I will succeed. Echo is a valid command in bash. So then you can echo the exit status and it will be 0 because it's successful. True and false are also bash commands that give specific exit codes. So if you just type true and then you want to see the exit code, it's 0. If you just type false, the exit code is 1. If you do and or operators, then conditional execution occurs when the execution of one program depends on the exit status of another program. So here you might type true, which gives you exit status 0, and then it will echo program 1 was executed, because in the case of the AND operator, the program on the right-hand side of the AND sign will only be executed if the program on the left-hand side has an exit status of 0. So it's essentially a way of only conditional on whether your exit status is 0 or 1, will it run a certain program. So in this case, the output will not, it will only show program 1 was executed because this exit status is 0. False gives you an exit status of 1, and it will not run this, it will not echo this line. A similar thing applies to the OR operator. Commands on the right-hand side of the OR operator are only executed if the command on the left-hand side fails. So it's basically the opposite of this. So here only program 2 was executed. Okay, we're doing on time, we're all right. You can also construct conditional expressions, which are logical statements that are either equivalent to true or false. Conditional expressions are always between double brackets. So here we can use the greater than flag. So here you're saying if this statement is true, we're just supplying this. This will give us true or false. Remember, true or false have some exit status, right? 4 is not greater than 3. 4 is greater than 3. Sorry, it's later. It's like 1 a.m. 4 is greater than 3. So the exit status will be 0. 3 is not greater than 4. So it will evaluate to false, and it will give you exit status 1. Then these binary logical expressions compare 2 values. There are also unary logical expressions that only look at 1 value. For example, you can test whether or not a file exists using the -e logical flag. So let's look at this flag in action. Here we have a conditional expression again. We want to start with this. We want to see, does the file called var.sh exist? If it exists, it should echo true. If it doesn't exist, it should echo false. So yeah, note that there are if and else statements. If statements evaluate conditional expressions. If an expression is true, then the code within an if statement is executed, otherwise just skipped. Elif and else statements also help control the flow of a bash program. And if statements can be nested within other if statements. So this needs an example. We have another shell script written here called guess.sh. It's a longer program, but bear with me. It will prompt you to enter a first number. It will then read your response, store it into var1. Same thing for var2 and var3. And then this is a program that has a bunch of conditional expressions saying if var1 is greater or equal than var2, then it will compare var1 to var3 and then echo var1 is the largest number. Otherwise, var3 must be the largest one. And if we follow the logic here, also note that we close an if statement by fi. This is quite weird. We don't use it in other languages. If we follow the logic here, then we have the final possibility that var2 is the largest number. So much like any other programming language where you can use if and else. There's also a bunch of handy references for this. I know it's a lot we're covering all at once. Don't despair. Note that we, as I said, fill out the canon request form that I showed earlier. In your R Markdown, you should be able to see the link at the beginning. I can also put out, oh no, we already put out an announcement, I think, earlier with this link. This is really important, so try to do it today. Then I think probably tomorrow you get an email saying that your account has been created. You'll have to, before you use it, reset your password. There's all the links for that. I will Oh, these slides are already posted, by the way, in the GitHub right here. These are posted under getting started with Canon.pdf, so you'll be able to see it later. You also need to set up two-factor authentication, probably with a Google Authenticator, and it's all pretty neatly described. And only then you can continue. This is the more important part. Once you have your account set up, you really need to do all these steps first, otherwise we won't let you log in. You will need to type SSH and then your username. So sub in whatever username you sign up for or is assigned to you here. So for me, it would be mdevries, for instance, at login.rc.fast.harvard.edu. It will prompt you for your password and your authenticator code. And then to navigate to the course folder, you type this command, and this will make sure you're in the Style 115 class folder, and then in the right year. Yeah.
So pretty much like this is like a virtual like desktop that we have access to. So
yeah, this is the folder that's on the computing cluster where you will find your homework files that you need for the homework.
So could we work on our homework files directly from the cluster?
Yeah, let me think about that. What you mean by that?
Like, could we just do like the RStudio things within the cluster itself?
Yeah. So usually,
like, does it have a? Is it just a command line? Is that all it is?
Yeah, basically, it's a command line where you can access certain files and where you can run certain commands. I think I'll need to add a little bit of explanation to this in terms of for homework 1. We'll also get into that next week a little bit because it takes a little bit of care where you run your commands. And I know I'm not clearing anything up now, but it could, for instance, be that if you are in your cluster and then you run certain commands, you will add a bunch of files to the folder in the cluster that then everyone can see. And then that's not really useful. So there's a way to do that better.
What would our username be?
I think you can sign up for that actually in the form. And if not, it will be just assigned to you.
And are these slides available on Canvas?
For now, I have them in the GitHub here under this getting started with Canon PDF. But
okay, that's perfect.
I just think I'll just.
Is a GitHub link also like on Canvas?
I'll have to check, but it's just github.com/tab115.